Welcome to the video, guys. My name is Pushpinder Gill, and today we're going to do the properties of graph functions. So this is going to be the first video on that. So this video would relate to students who are writing their GRE exam and the students who are writing the SAT, right? There has been some questions about that. It's going to be very limited for GMAT students. There had been some questions relating to graphs in the GMAT, in the official guide as well, and in the GMAT prep as well, right? So there have been few questions, so it would be good that GMAT guys know about this in case they're planning to get a 51 or that is the perfect score, right? So for SAT guys is the utmost important, and for GRE also it's very important that they learn to understand about the functions. I'm going to cover everything that is there in the test in this video only, right? So I'm going to be just talking about applications. This is not going to be a boring video where I start picking up maths and start explaining you what is a hyperbola, what is a parabola and all that. No, it's not going to be like that. So before we start the video, make sure that you explore more about us on perfect-score.com. You like our Facebook page, that is facebook.com/perfectscores. And if you have any feedback about anything, in case you want to join a GMAT batch, in case you want to join a GRE batch, you want get some tutoring services and all that, you can give me a feedback or ask a query on perfectscores89@gmail.com. So let's go ahead and get started, guys. So now we're going to do graphs. So I suppose you already know the basics about it. In case you haven't, I would advise you to go ahead and watch the coordinate geometry 1 and 2 videos, which are available free of cost. Anyhow, we're going to cover the basics right here. This would be the y-axis, right? And this over here is going to be the x-axis, right? And this over here is the origin. So something very important, all the points on x-axis, the value of y is going to be 0. And all the points on y-axis, the value of x is going to be 0. Slope of a line is given as y2 minus y1 upon x2 minus x1. I suppose that is one thing here, that if there is a line, the slope of the line would be given as, let's suppose it passes through these 2 points x1 y1 and x2 y2. Then the slope would be given by using this expression. So I'm just summarizing what I have covered in the last 2 videos, right? And the y-intercept is the value of y when x is equal to 0. So this would be the y-intercept of this equation, and x-intercept is equal to the value of x when y is 0. So this would be the x-intercept. Now these 2 points are very important when it comes to solving the graph problems, right? So they are very critical. So let's go ahead and get started with our stuff here. So first thing that I'm going to do is reflection. Okay, now you will get a lot of questions. So first I'm going to cover the theory, then we're going to do some questions based on that. Some, not a lot of questions. So reflection means, let's suppose I have this graph here, right? And there is this point that is 4, 3. Now if I want to reflect this point, with respect to x-axis, so if I want to reflect this point with respect to x-axis, making this as the mirror, then the point would become this, and the coordinates of this point would be 4, -3, right? So if I reflect it according to x-axis, the coordinates would be 4, -3. Similarly, if I reflect this point according to y-axis, the coordinates of this, if I make this as the mirror, then the point would look like this, and the coordinates of the point would be -4, 3. And I reflect it according to x and y axis, then this point would become this. That means it will become -4, -3. Now see the change here. When I reflected the point according to x-axis, what changed? What changed for 4, 3 to -4, -3? The x remained constant and the y coordinate changed. Similarly over here, when I reflected 4, 3 according to y-axis, the y remained the same, the y coordinate remained the same, and the x coordinate changed. and when I reflected according to both the axes, both the signs of both the coordinates x and y changed in this figure over here. That means that brings me to my first point when it comes to graphs. That is, when you reflect something according to x-axis, the y coordinate changes, right? So the y coordinate is going to change. Similarly, when I reflect something according to the y-axis, the x coordinate changes, right? And when I reflect something according to both the axes, then both the coordinates change. Now let's suppose if I say, what will be the reflection of, let's say, this line here with respect to x-axis? So I have to reflect this line according to x-axis. Now what happens with x-axis? Now it would be very tricky if you do it diagrammatically, but see here, when I reflect something according to x-axis, the y coordinate changes. Now over here, the y coordinate is already 0. That means this point is not going to change at all. But at this point, the y coordinate is a positive number, which is gonna become a negative number. That means this is the point where the line would be passing through. That means the reflection would be this, right? So suppose you're understanding, when we reflect something according to x-axis, the y coordinate changes, and when we reflect something according to y-axis, the x coordinate changes. Okay, so we're gonna bring a question on that a little later in the video. So I suppose you've understood the concept here, and we have done one small little question here as well, which make you understand. So reflection of, let's say, this line with respect to y-axis, the x coordinate is gonna change, but the y will remain constant. So this would be the reflection with respect to y-axis, and this would be the reflection with respect to x-axis. But with respect to x-axis and y-axis, both of them are going to change. That means the line is going to become something like this. So suppose you've understood this reflection. GRE guys, very important for you. So let's move forward, guys. Okay. Now, generally, I'm not talking from overall point of view. Generally, you get two types of functions in your standardized exams. First is the linear functions, which is pretty much your linear equations, and the general form of linear functions is y is equal to mx plus c, right? So these are the linear functions, which is a single line, right? So these all are linear functions which has the coefficient of x as 1, the power of x. Then the next type of function which I'm going to focus more in this video are quadratic functions, where the maximum power of y is 2, right? So this is the general form of a quadratic function. Now very rarely you're going to use the general form. Don't worry about that, because I won't let you use the general form. We're going to do the question in a logical way rather than, a mathematical or equation way. So a quadratic function, that means for two values of x, this means that for two values of x there is a single value of y. That means for two values of x there is a single value of y. For two values of x there is a single value for y, and there is going to be one value of x which is going to give a single value of y. Well, this is how the graph is there. So this is how the graphs are there. For one value of x there are two values of y, right? So this is how a graph is there. So we're going to do this in more detail first. So this are the quadratic function, and this over here is a linear function. So I suppose you've understood these two different types of functions. So let's move forward. Let's learn more about quadratic functions. Now first thing is their general equation. So generally y is equal to ax square plus bx plus c, right? So that means this over here is gonna have two values of x. So there would be two values of x that will give the value of y to be equal to 0. There will be two values of x which will give me the value of y equal to 0. So in mathematical language, these are called the roots of the equation. So the roots of the equation is the value of x when value of y is equal to 0. So there is something known as the determinant of the equation. Now what is the determinant of the equation? It determines what is the nature of these two values of x. So if this is a general form of a quadratic equation, determinant is going to be b square minus 4ac, right? So if I have y is equal to 2x square plus 3x plus 4, that means a is 2, b is 3 and c is 4, right? And then I'm going to find out the determinant of this equation, that would be b square minus 4 into a into c, right? So this is going to be the determinant of the equation. Let's call it d. Now d over here is greater than 0. If d over here is greater than 0, that means there would be positive and two different real values of x when y is equal to 0. So when this determinant is greater than 0, there are two different positive values of x when y is 0. That means the graph of the equation is going to cut x at two different points where the value of x is equal to 0. This would be like, this would not be, this would very well be a different equation. So when value of d is equal to 0, then there is only one value. So remove this positive, it need not to be positive. So when d is equal to 0, there is only one value of x where y is equal to 0, right? That means the graph just touches the x-axis. And when this determinant is less than 0, there is no value of x when y is equal to 0. That means the roots are imaginary. That means the graph never touches the x-axis. So this is a quadratic equation. This is something that you would be using very rarely, right? If you are a newbie to standardized testing, you would definitely be planning to use all this information. But believe me guys, this is not what is required. This is something that is required for you to understand the whole quadratic function. So the general form of a quadratic function is this. There are two values of x at which y is equal to 0. Then there is a determinant, right? A different determinant, right? That determinant would be b square minus 4ac. If it's greater than 0, then there are two different values of x when y is 0. If determinant is 0, there is only one value of y. And when determinant is less than 0, there is no value of x where y is 0. So basically, this says that there are two distinct roots. This says there is just one root of the equation. That is nothing but, let's say, x minus 2 whole square. There is just one equation, that is x is equal to 2 is going to make y equal to 0, right? So just one root out of it, and over here there is no root at all. So suppose you've understood this question. Let's understood this concept here. Let's move on to more solid points which will help you to get to the answer. So guys, this point over here, I'm going to give it 5 stars, because if you understand this, you will be able to solve so many GMAT, GRE, SAT questions with such ease, even CAT questions with such ease. You're going to solve these questions. Now, what is symmetric? Symmetric says that all quadratic functions are symmetric in nature. What do you mean by symmetric in nature? Symmetric means that if I draw a line, if I take the lowest point and I drop a line from its lowest point, the area covered by the graph to the left of the lowest point and the area covered by the graph to the right of the lowest point would always be equal, right? So let's suppose if this is a graph and this over here is the lowest point, then if this is minus 3, that means distance from here to here is 3. That means distance from here to here would be positive 3. Similarly, if I say that this over here is negative 4, distance from here to here is negative 4, distance from here to here would be positive 4. Similarly, if I drop a perpendicular from here and I drop a perpendicular from here, the distance from here to here will be equal to distance from here till here. Let me draw another diagram and show you that. Let's suppose this is a graph and this is the lowest point, and if I drop a line from the lowest point, that means distance from here to here is going to be equal to distance from here to here, right? Similarly, distance from here to here is going to be equal to distance from here to here, and the area covered by graph on the left hand side would be equal to the area covered by the graph on the right hand side. So I suppose you're understanding this point over here, guys, that the graph is always symmetric in nature. So let's give you a question. Okay, so let's suppose the question is like this, that the minimum point is let's say -2 comma -3. All right, if this over here is -1 comma 0, then what is this point? Now if I drop a line, sorry, this is not negative, let's suppose this is -3. Let's not say -3, let's say -5. Sorry about that. So if I drop a line from the lowest point, this is -2 and this is -5. So this over here is also -2. That means distance from here to here is from -2 to -5, that means 3, which means distance from here to here will also be equal to 3. So distance from here to here is 3 and this is -2. From here to here the distance is 2 and from here to here the distance has to be 1, so that the total distance becomes 3. That means this over here would be 1 comma 0. So suppose you're understanding my point here, guys. This is very, very important, that the graph is symmetric to nature. From the lowest point it will always cut the graph into two equal halves. So from the lowest point or the highest point, the graph or the highest point, the graph would be cut into two equal parts, right? So graph will cut in two equal parts. So I suppose you are understanding this question over here. Let's move forward. Let's test the another property. All right. So I hope you have noted down this. We're going to cover a lot of questions on this. All right. Now let's suppose I talk about a quadratic function. Let's suppose I talk about this function y is equal to x square. So if I draw the graph of this function here, the value when x is 0, then y is also going to be equal to 0. That means there is a point over here. When x is 1, y is going to be 1. When x is 1, y is going to be 1. When x is -1, y is going to be 1. When x is -1, y is going to be 1. When x is 2 or -2, y is going to be 4. When x is 2 or -2, y is going to be 4. That means the graph is going to look something like this. So this is the graph of y is equal to x square. Now what is f of x? F of x is nothing but, my way of saying, is equal to y. F of x is nothing but y here, guys, right? That is the way you denote a function, right? Now if I say f of x is equal to y, right, and if I say I do f of x plus 2, if I add f of x plus 2, that means in this function, if I say what will be the graph of x square plus 2, or what will be the graph of f of x plus 2, then if I draw this graph again, x equal to 0 would give me y equal to 2, x equal to 1 will give me y equal to 3, x equal to 0 will give me y equal to 2, x equal to 1 will give me y equal to 3, same goes for -1. That means this graph is going to shift up by 2 units, which means any quadratic function, if it's y is equal to f of x, if I do f of x plus a, the graph is going to shift up by a units, right? So I suppose you're understanding that the graph is going to shift up by a units. Similarly, if I draw the same graph again and I have to say y is equal to f of x, and I say y is equal to f of x minus a, the graph is going to shift down by a units, right? So it shifts up by a unit, so it's going to become something like this, right? So the graph is going to shift down by a units if I say y is equal to f of x and I say y is equal to f of x minus a. Now let's see another twist here. The another twist would be, what about if I say y is equal to f of x plus 2? If I say f of x is equal to y, which is equal to x square, the graph is going to look something like this. Now, if I say what will the graph of f of x plus 2 look like, that would be equal to, if I go by this graph, instead of x, I will replace it by x plus 2. That would be x plus 2 whole square. Now think about this. Tell me which value of x, just tell me which value of x will give y equal to 0. So which value of x will give me y equal to 0? Yes, x equal to negative 2 is going to give me y equal to 0. That means negative 2 comma 0 is on this graph, which means if the lowest point is here, the lowest point is going to shift to the left by 2 units and the graph is going to become something like this. I'm going to repeat once again. If y is equal to f of x and I say x plus 2, right? Instead of doing x plus 2, I'm doing x plus 2. Now you tell me which value of x gives y equal to 0. That is x is equal to negative 2. That means the graph is going to shift by left by 2 units. So if I say y is equal to f of x and this is one graph, and I say another graph is there where y is equal to f of x plus a, in this case the graph will shift to the left by a units, right? So the graph will shift to the left by a units. Similarly, if I say y is equal to, instead of I cut this and I say y is equal to f of x minus a, then the graph will shift to the right. This is shift to left, then shift to right by a units, right? So suppose you're understanding this. This is a very, very important step, right? So if you understand these things, you don't have to worry about doing maths in the question. You just have to worry about being logical in the question. Let's move forward, guys. Okay. So let's do another concept. If I say y is equal to x square, okay. So if I say the value of y is equal to x square, the graph is going to look something like this. Similarly, if I say y is equal to 2x square, so if y is equal to 2x square and I put x equal to 0, x square becomes 0, 2x square becomes 0. If I plug in x equal to 1, this is 1, this is 2. When I plug in x equal to 2, this over here is 4 and this over here is 8. That means for the same value of x, I'm getting a bigger value of y. For the same value of x, what am I getting? I'm getting a bigger value for y, which means my graph is gonna shrink by when I multiply a graph by a number greater than 1. So when I multiply the coefficient of x square by a number greater than 1, what is going to happen to graph? The graph is going to shrink. Similarly, if I say y is equal to 0.5x square, then for the same value of x, what am I going to get? I'm going to get a lesser value for y. For the same value of x, I'm going to get the lesser value for y. That means for the same value of x, there's a lesser value of y. For the same value of x, there is a lesser value of y. That means my graph is gonna become wider, or the graph is going to expand in this case. Which means if I multiply the coefficient of x square by a number between 1 and 0, then the graph is going to expand. Similarly, if I say y is equal to negative x square, so if I say y is equal to negative x square, then for the same value of x, negative x square is going to turn out to be a negative number. If the graph looks like this, the graph is going to flip back like this. So over here, the graph will flip. Similarly, if I say that y is equal to negative 2x square, then it will flip as well due to negative, and due to 2, it will shrink. If I say y is equal to negative 0.5x square, it is going to flip because of a negative sign, and it is going to expand. Right? So suppose you're understanding all this, what I've done here, guys. Pretty easy stuff, but you have to note all this down. So I'm going to put it in terms of all the points. I'm going to cut out all the behavior of graph. So I would like to call it how the graph behaves. So if I say y is equal to f of x, and if I say f of x plus a, then the graph goes up by a units. Similarly, if I say f of x minus a, then it goes down by a units. If I say f of x plus a, it's gonna go to the left by a units. If I say f of x minus a, it's gonna go right by a units. Similarly, if I say y is equal to something a x square plus something something something. If I say y is equal to 2x square or ax square, let's say ax square. If a is greater than 1, then the graph is going to shrink. If a is less than 1 but greater than 0, then the graph is going to expand. If a is less than 0 but greater than negative 1, then the graph will flip plus it will expand. And if the graph is less than, if a value of a is less than negative 1, then the graph will flip plus it will shrink. Right? So this is the behavior of a graph that you need to understand, and believe me, if you understand all this, it's all logic that will help you in your questions. I suppose you're understanding this, guys. Let's go ahead and solve some questions on. So let's go ahead and do this question, guys, over here. We're going to solve these questions. They're going to help you really and understand it's more about logic and less about maths and less about all these things. Now in this question it says that the graph of the function is this. So f of x is given to you as 3x square plus 4 minus 8x. Now whenever you do graphs, always focus on 3 points. Always focus on origin, always focus on the x-intercept, and always focus on the y-intercept. Now let's focus on this point here. Now at this point the value of y is 0, and at this point the value of x is 0. Now when the value, now in this equation is this, when the value of x is 0, y is pretty straightforward 4 here, because this becomes 0 and this becomes 0, y becomes 4. That means the value of x is 0, then value of y is 4. That means distance from here to here is equal to 4. And when the value of y is 0, then if I just plug it back into this equation, 3x square plus 4 minus 8x is equal to 0. That means 3x square minus 6x minus 2x plus 4 is equal to 0, which means 3x into x minus 2 minus 2 into x minus 2 is equal to 0. That means x minus 2 into, so I think it's gonna be, yeah, so into 3x minus 2 is equal to 0. Right? So I think I have made a mistake here. 3x square plus 4 minus 8x is 0. 3x square plus, this is the case, and I'm gonna straightforwardly this out and this out, 6 into 2. So that means x equals to 2 satisfies that, and x equals to 2 by 3 satisfies that, right? So I got these two values over here. x is equal to 2 and x is equal to 2 by 3. Now since 2 by 3 is a smaller amount, that is going to come here and 2 is going to come here. So over here x is equal to 2, which means distance from here to here is equal to 2. So the question here is asking what is the area of the rectangle. So the area of the rectangle is going to be the length into breadth, that is going to be 4 into 2. That would be equal to 8. So 4 into 2 is going to be equal to 8, which is nothing but my answer, option C. So pretty good question, guys. It's a hard question, believe me, but we're able to do it with such sophistication. Why? Because we know these 3 points to focus on, and we know that the graph, we just focus on these points. That's what we do, right? So I suppose you're understanding this, guys. We've done it with such simplicity, and that's what we're going to do throughout the video now. Let's see another question. Now this question over says that the graph, please don't mind my my drawing here. The graph in the figure is defined as y is equal to fx. So this over here, y is equal to f of x. If h of x is defined as, so h of x is equal to modulus of f of x, which means h of x is equal to modulus of y. That is there. That means because y is equal to fx, then which of the following is a graph for hx? Now, what is y here? Y over here is all these values. And when I talk about modulus, it is always positive or 0, right? It can never become negative. That means the graph of h of x will never be in this zone. That means the value of y will always remain positive. Over here the value of y is positive, negative. Over here the value of y is negative, and over here whole of y is negative. This is the only graph where the value of y is not negative, right? So pretty easy question. Not so easy if you don't follow the basics. Only the basic is that in this question, if I say h of x is equal to modulus of f of x, that means no matter what value of f of x is there, always the y is going to remain positive. That means this is how the graph is going to look like. So suppose you've understood this one over here, guys. Let's move forward to the next question. Now let's see this question over here. The question says that the function in the figure is defined as f of x is equal to ax square minus 4. If another function is defined as let's call it g of x is equal to 2ax square minus 4, then the graph will be closest to which of the following. So over here it's asking what will happen to this graph. Now as you can see, my coefficient of x square is multiplied by 2. So over here the number that is multiplied is greater than 1. As we've done in our concepts, the graph is going to shrink, right? The graph over here is going to shrink further because I have multiplied it by 2. That means this is my answer. It will not move up, it will not expand, it will not move to the left, it will not move to the right. It is going to shrink, and C is my answer. So I suppose you've understood this one, guys. If you've paid attention to the concept that we have built, if you've understood that, it's a pretty straightforward question. And believe me, guys, all these questions are hard questions. They are not easy questions. But we're able to do it with such simplicity because we are just using the applications of what we have learned. So let's move to this question. So this question says that in this figure, a square is intersected by the function this is asking you the value of k. Again, focus on these points, guys. This point, this point, this point, and this point. Focus on these points. The function is y is equal to kx square. And it says, and since this is the smallest point, according to symmetry, the distance from here to here would be equal to the distance from here till here. Which means if area of the square is equal to 64, that means side of the square is going to be root 64, which is 8. Because area is equal to side square. That means distance from this whole distance is 8, which means this is 4 and this is 4. Now, if this is 4, then you can pretty much be sure about that this is 8, right? and this is 4 and this is 4. That means this over here is going to be x equal to 0 and y equal to 4, and this is going to be x equal to 0 and y equal to 0. This point over here is going to be 4 comma 4. This point over here is going to be negative 4 comma 4, and these 2 points lie on the function, which means 4 comma 4 lie on the function. That means 4 comma 4 is on the function, and if I plug these values back into this, I would be getting y, that is 4, is equal to k into x square, that is equal to 16. That means k is equal to 4 by 16, which is 1 by 4, which is equal to 0.25. Even if you want to double check your answer, plug your answer option back into this point. It should be satisfying this point also. That means y is equal to 1 by 4 x square. That means 4 is equal to 1 by 4 into negative 4 square. That means 4 is equal to 4. That has proven my answer. So again, I'm repeating, I just focus on these points, guys. I just found out the coordinates of these points using the symmetry, and this is what we did. So this question uses the symmetry. So use the symmetry to your advantage, guys. Okay. So suppose you've understood this one over here. Let's move forward to the next one. Now, in this question, it says there are two functions f and g, and f of x is equal to x cubed minus 4x. So f of x over here, so this is f of x, is equal to x cubed minus 4x, and g of x is equal to f of x plus p plus q. Now, when you do f of x plus p, the graph moves to the left by p units, and when you do plus q, the graph moves up by q units. Now over here, this graph, over here the graph has actually moved, has it moved to the left by q units or has it moved to the right? So over here, if we focus on the, so it says x cube minus 4x, so it says f of x plus p into q. So the graph, if we look at the lowest point over here, so if we look at the lowest point, this is negative 3, and this becomes negative 2, right? That means the graph over here has actually moved down. If the graph has moved down, that means the value of q must be negative. That means q must be equal to negative 2. And the graph has actually moved. If I look at this highest point here, the value of x is negative 1, and over here the value of x is 2. That means from negative 1 it has made a distance of 3. That means it has actually moved to the right. That means the value of p must be equal to negative 3. And over here the question is asking the value of pq. The value of pq over here is going to be equal to 6. So suppose you're understanding over here, the graph actually moves to the right and goes down. If it moves to the right, then over here the value of p must be negative, definitely, because only when there is a negative here the graph moves to the right, and it goes down. That means the value of q must be negative here. Only when the value of q is negative, when this is negative, the graph goes down. So this is what it's saying, f of x and g of x, right? That means q is this and p is this, and pq is equal to 6, which is my answer, option E, right? So suppose you've understood this one, guys. Here, let's move on to the next question. Now over here the question says whether the following represents the equation that modulus of x is equal to modulus of y. Now we're going to focus on few points here. When x is equal to 1, y is equal to 1, or y is sorry about that. When x over here is equal to 0, y is equal to 0. That means it must pass through the origin, which is done by all the cases. When I say x is equal to 1, y can be positive 1 or y can be negative 1. That means as x equal to 1, there must be two values of y, which is not here. When x is equal to 1, there must be two values of y, which is not here. When x is equal to 1, there must be two values of y, which is not here. When x is equal to 1, there must be two values of y, which is not here. When x is equal to 1, there must be two values of y, which is here. Similarly, when I'm left with one option, I'm just going to play around here. When y is equal to 1, value of x is also, there are two values. When y is equal to 1, there are again two values of x. That means this is the function which best describes this. So guys, always go for elimination in these kind of questions rather than you trying to prove stuff. Always go for elimination. It's very, very easy to eliminate. Right guys? So I suppose you've understood this one over here. Let's move on to the next one. So the question over here says that the figure shown above, in the figure gx is shown, that means this is g of x. It says that g of a is 1, then which of the following must be true? Now this over here says that g of a is already given to be 1, which is g of 1. G of 1 is equal to 0. That means when I plug in x equal to 1, y should be 0. That means when I plug in x equal to 1, y should be 0, which is true. That means, this is satisfying. This over here, if I say g of a, which is 1, is equal to 1, that is wrong because g of 1 is 0. Now this says that a is equal to g of a, right? So it says that the value of a is equal to g of a. G of a is 1. That means it says that the value of, g of a is 1. That means the value of y is equal to 1. When is the value of y equal to 1? There are actually two values. There cannot be one value for a satisfying this, right? That means this is eliminated. Similarly, if I say a is equal to 0, over here the a is definitely not 0 because it says that g of a is 1. That means while value of y is equal to 1, value of y is equal to 1 is true here and is true here. That means definitely a is greater than 0 and less than 0. That means this is also eliminated. And it says that which of the following must be true. A can be equal to 1, a can be equal to -1 also because there are two values of a. That means this is also eliminated. Hence a is my answer. Right? So suppose you're understanding this, guys. I'm going to repeat once again. Now in this question it says the value of g of a is 1. If g of a is 1, that means when a is equal to, when y is equal to 1, the value of x is equal to a. When y is equal to 1, the value of x is a. It can be 1, it can be it can be something. So there are two values for a. That means there cannot be a definite value for a. That means these are eliminated. This is pretty straightforwardly eliminated, and this is the only answer option satisfying given in the question. That means my answer is option A. Fine guys, I suppose you've understood this one. Let's move on to the next one. Now this over here is a reflection question. Now the question says which of the following will be the reflection of the line with respect to x-axis. So we're going to focus at this point. This point is going to be something x and y is 0. Right? This is going to be something x and y is equal to 0. And when you reflect something with respect to x-axis, the y coordinate changes. So over here, when the reflection is going to have the same x coordinate, but the y coordinate is going to change, but 0 when it changes, it remains 0. That means this point is going to remain intact here only. And at this point, the value of x is 0 and there is a value of y, which is going to become negative when it reflects because the value of y coordinate changes, and the reflection is going to look like this, which is this answer option. So suppose you're understanding that the only key to the question is when you reflect something according to the x-axis, the y coordinate changes. When you reflect something according to the x-axis, the y coordinate changes. Fine guys, I suppose you've understood that. Let's move on. Alright guys, so thank you very much for watching the video. So we've done a whole lot of functions. So these are the questions that can make or break your test, especially for SAT guys and GRE guys. This is very, very important. And for GMAT guys, just to let you know that in OG there are a couple of questions which test symmetry. right? That means you can get questions with test symmetry. And if you buy a GMAT prep test 3, if you buy test 3 and or test 3 and test 4 from GMAT prep, you're gonna get a question on y is equal to f of x plus 2, right? That means, yeah, pretty much, GMAT is also aligned with that, but not so much. Very rarely they're gonna ask you a question on that. But when it comes to SAT and GRE, guys, it's very, very important. CAT, guys, you can always expect anything to come when it comes to CAT. There are a lot of questions in previous CAT that have been testing symmetry, that have been testing the behavior of the graphs. So there are a lot of questions on that. So this would be about the video, guys. Don't forget to explore more about us on perfect-scores.com, our Facebook page, and send me your valuable feedback in case you're looking for tutoring services or anything like that. You can always throw in an email. So this would be about the video, guys. Thank you very much, and I will see you in the next one.